We're going to go through the rules of nomenclature for cycloalkanes, and it's very similar to what we learned with acyclic alkanes, where we find the parent, identify the substituents, and put the name together. So we're going to go through some of the key features that differentiate this from acyclic alkanes. So first, we have to find the parent. In most cases, the parent is just going to be your ring. So here we have this 5-carbon ring with 2 substituents on it. The parent is cyclopentane. Now, in some cases, the chain can be the parent, but it's really only in a couple of scenarios. The chain has to have more carbons than the ring, and also the ring can have no other substituents, because then it becomes difficult to name. So in this case, if we look, we have a ring that has 3 carbons. We have a chain that has 4 carbons. So the chain has more carbons. Also, the ring doesn't have anything else attached to further complicate it. So in this scenario, the chain is the parent. And then we just revert to our nomenclature rules we learned with alkanes. So we start numbering at the end where we have our first substituent, like this. Notice that I did not include any of the ring carbons in my count. So you have to separate your ring and your chain. So the carbon of the ring can't also be a carbon of the parent chain for the alkane. Likewise, up here, we can't have any of the alkane or the substituent carbons in the parent ring. So now what we want to do is treat this cyclopropane as a substituent. So the same way if you had methane and that became a methyl group, the cyclopropane, since it's a substituent, it becomes a cyclopropyl group, and it's at carbon 1. So when we name this, we have 1 cyclopropyl butane. The next thing we have to do is number our parent. And this can be a little trickier than the alkanes because on alkanes you have 2 ends to choose from. On a ring, you really don't have any end. So you have to figure out where to start your numbering, where to end your numbering. So a general rule, we always start at a substituent, and then from there we can number clockwise or counterclockwise with the overall goal of giving the lowest possible substituent numbering. So there's multiple ways we could potentially number this tri-substituted cyclohexane here. I'm going to go through a few ways with you and compare. So let's say we start at this methyl group and number clockwise. Okay, we get that numbering scheme. Let's say you decided to start at this methyl group and number counterclockwise. Let's do one more. Maybe you decided to start at this methyl group and number clockwise. There's some other possibilities, but I think you can see some ways that we're going to get lower numbering than others. So the easiest way to deal with this then is figure out where you have substituents and just add up the numbers. So in this first one, we have a substituent at 1, at 3, and at 4. So just add 1 plus 3 plus 4, that's 8. Okay, let's do that with our second one. We have a substituent at 1, 2, and 4. Add those up. That gives us 7. All right, and then let's do our third example. We have a substituent at 1, 2, and 5. That gives us 8. So of these, our lowest numbering here is the one at 7. That wins. So that is the numbering scheme that we want to use. Again, sometimes this takes some trial and error, but you can imagine, a good place to start is going to be on one substituent, and then, it wouldn't make much sense to number in this direction because you're going to, have a couple of blank carbons before you land on your second substituent. So you can capture all of them in just the first 4 carbons in this direction. So you can use a little bit of deduction to figure out the best scheme, but sometimes just do your trial and error, add the numbers up, and pick the lowest. If you do happen to run into a numbering tie that you can't break, then use alphabetical as a last priority. So in this case, it doesn't matter if I number clockwise, 1, 2, or 3, or counterclockwise, 1, 2, and 3. I'm going to have something at 1 and something at 3. So in this case, use alphabetical priority to break the tie. Is it better to have a 1 for the methyl, or is it better to have a 1 for the ethyl? E beats M alphabetically, so we want the 1-ethyl, and that'll be the 3-methyl. So this numbering scheme in blue is our preferred scheme. Now we have everything we need to assemble and write an IUPAC name for cycloalkane. So in this example, we have a 7-membered ring. That's going to be our parent. So our parent is cycloheptane. Then we need to number this, and you can imagine either starting at the bromine and going clockwise, or starting at the tert-butyl group and going counterclockwise. One of those will give the lowest numbering. So if you start at the bromine, we would get something at 1, 3, and 4. That adds up to 8. If you start at the tert-butyl, you get something at 1, 2, and 4. That adds up to 7. So starting at the tert-butyl is going to give us a lower numbering. So let's do that. That's really all we need, but I'll finish numbering around the ring. All right, so now we'll identify our substituents. At carbon 4, we have a bromo. At carbon 2, we have a methyl. At carbon 1, we have a tert-butyl. So we need to alphabetize the substituents, and we alphabetize based on the B in bromo, the M in methyl, and the B in butyl. So you'll have to go to BU and BR. Let's alphabetize these. So we have the bromo first for bromo. Then we have 1 tert-butyl. Then 2-methyl. And the parent, cycloheptane. Okay, I want to reiterate a common mistake. There is no dash between the last substituent and the parent. or no hyphen. You just butt the parent right up against the last letter of the substituent.